All right. What's your name?
My name is Russell Hewertson.
And Russell, what's the company that you work for?
I work for Air Products and Chemicals. It's an industrial gases company.
Um, what kinds of gases are sold to the aluminum industry and for what purposes?
So we sell oxygen, which is used for oxygen-assisted melting. So whether it's oxygen enrichment, oxyfuel burners for rotary or reverb furnaces. We sell nitrogen and argon for aluminum degassing. We also sell nitrogen to aluminum extruders for helping to improve the extrusion process, and sell nitrogen to aluminum annealers, use the nitrogen in their annealing furnaces to get better surface finish and maximize the safety of that operation.
Okay, well, let's talk about in the furnace operations. And specifically, in what way is the air delivered?
So for melting operations, we can do anything from enriching customers' existing air to get more production. Usually though we use oxyfuel burners, so we use natural gas or oil and pure oxygen in a burner that's designed by Air Products. And we use those in rotary furnaces for increasing the productivity. You can typically get about a 30 to 40% production increase on a rotary furnace. And then we also boost reverb furnaces, particularly when an operation is looking for more production, like a lot of the rolling mills now with the demand in the auto industry are looking for more production in their cast houses. So we can use oxygen assisted melting technology to get more throughput from their existing operations.
Okay, I feel like I've right away stepped ahead of finding out about you personally, Russell. How did you get into the aluminum industry or the gas industry
Sure,
first?
yes. So I'm a chemical engineer by training, and you can tell from my funny accent I'm from the UK originally. I'm actually a dual national. I was born in the US, grew up in the UK, and I work for another company in the close area where Air Products headquarters is. And I was hired by Air Products onto what they call their career development program. You try little different areas, try a job in 1 year in one area, then another, and then another.
When was that?
And that was in 1989. So my second assignment, I worked in the aluminum industry, and I loved it so much. I've been working in that area ever since, in the applications area.
So your entire aluminum career, you've been with Air Products?
I have, yes.
It's a little unusual.
Yes, it is very unusual. Yeah, I think what I like about the job is we're all about working with our customers to help the customer get better results. So there's having a technical background as a chemical engineer. It's a combination of solving problems, but also looking at the economics, making sure that we can improve people's bottom line, and working with them in tandem as we develop new technologies. We've had many customers since late 1980s that we've been working with on the aluminum side of things, where we've gone through about 4 generations of technology, improving their performance each time.
Could you walk us through maybe an installation not too long ago for automotive sheet, for example?
Yeah, sure. So we've worked recently with a company called Sapper Aluminum on the extrusion side of things. Basically, there we work with them to increase their production of their reverb furnaces. On the sheet side of things, we work with a couple of big operators looking at getting more production through their melt furnaces, and also improving the operation of their annealing operations. So where they use nitrogen for their annealing mills, we worked on optimizing their usage patterns and minimizing their costs of industrial gases.
Is the SAPA installation that you're referring to the one that had an article in Light Metal Age about?
It is, yes, at Cressida in Pennsylvania, yes.
Okay, and what was their initial problem that you guys found the solutions for? Because they had particular equipment already, and you had to look at what they had in order to optimize.
Yeah, so we've been talking to SAPA for quite some time, and when they first approached us and asked us if we could help them with their production increases, we said absolutely that we could, but we actually made some suggestions to them of other less expensive opportunities for them that would make sense for them to install before going with the Oxyfuel. Once they'd maximized the performance improvements that they could get from these other opportunities, they came back to us and said, "Hey, now that we've got everything that we can get with regenerative technology, with metal pumping, is there something else that you guys can add?" And that's when we got involved with them on customizing a design for the particular furnace that they had a limitation on.
So you even advised them on before your your product would be used. You kind of helped to set them up so that your product could be used most effectively.
Absolutely. At the end of the day, our company is interested in selling in the industrial gases to our customers. So we're a little bit different from a lot of equipment suppliers. We really want to make sure that the customers not only can use our technology in the short term, but for the long term. So we're less interested in selling someone some flow control skids and a burner, and more interested in having a partnership to allow them to get maximized production, better economics, and hopefully those will come with using our technology and our gases.
Well, I wasn't clear on how extruders use nitrogen.
Yeah, so when you extrude aluminum, there's a lot of heat generated as the billet is pushed through the die, and there's a lot of extra surface area is uncovered. So as we all know, oxygen is very easily oxidized. So you have this high temperature, so it's easily oxidized, and there's also a lot of heat being generated. So what we do is we design flow patterns within the die and cut grooves in the die tooling to allow the nitrogen to get into the process, and it really does two things. One is sweeps out the oxygen from the area, and secondly it provides cooling. So it allows aluminum extruders to run faster speeds, get better quality, run more with the same dies, and there's less scrap. And particularly with alloys like a 6061 alloy with high magnesium, you can see a very significant boost in the surface finish and the productivity available by using the nitrogen.
So when they would get a die maker would never know in advance to make holes for the nitrogen. I mean, how do you said you would take the die, and how would you make it so that the nitrogen could go through the die?
Okay, so typically, we get it into, we'll have a discussion with the extruder. We'll ask them, how many different shapes they run, how many die changes they have per hour, and depending on, some operations have a very small number of shapes that they run.
Yeah.
In which case we do grooving probably on the die backer, which is the piece right next to the die.
Ah.
If it's someone that has many different shapes that they run, we might groove the bolster, because for each bolster you might have 10 or 15 or 20 dies that you can use.
I see.
And really what we're doing is we're trying to make sure that the nitrogen is going in, it's spreading out evenly around the shape, so you're getting even flushing of the oxygen and even cooling. If you don't do it correctly, you can have shapes where the tolerances are not good. So if you have like multi-hole dies, you might have one shape running out longer than the others if you're not doing the cooling properly. And really what we do is we work with the die designers and show them the general concept, making sure that all the nitrogen is going where you think it's going. One of the things we often do is we'll go in and look at people's existing tooling, and we can point out errors and problems that they would have with the nitrogen with the current setup they have. And it's very simple once we've shown somebody the methodology to make sure that the nitrogen is being used effectively. It doesn't cost a lot, the nitrogen. It might be like $10 an hour's worth of nitrogen per press, but the benefits can be $100, $150 an hour. So it's a very nice technology.
Do most extruders use nitrogen?
Yes, I would say that the majority of extruders use gaseous nitrogen, although we do find when we go into extruders there are a lot of people that are paying for the nitrogen, but they're not getting the benefit because they're not doing it correctly.
Uh-huh.
So a lot of times we'll, by spending a bit of time in the customer site, looking at their operation, we can kind of point out some of the mistakes. Mm-hmm. A lot of times you might have what's called a double die slide press, where the tooling come in from one side or from the other. a lot of those tooling setups, they'll have an injection point for the nitrogen on either side, but they typically don't tend to block up the other hole. So sometimes they can be firing nitrogen in one side and it just comes out the other side. So there's things like that that, you know, once we show people, you know, how to do it more effectively, I think it provides a big improvement for them.
Will you be presenting any papers at ET, for example? Do you have any conferences coming up?
We may present a paper at the extrusion technology in Chicago next year. We also have papers that we're working on for oxyfuel melting on reverb furnaces. And again, that might be something that we present at ET. I don't know what the plans are in terms of the timing, but we do like to talk about the technologies that we've developed, and we're constantly working with our customers to address problems that they're seeing in the industry, or challenges, or opportunities for extra production.
Well, I know, Russell, when I look back in our database for articles that have appeared in Light Metal Age, your name has appeared a few times.
Yes. Yeah.
So that seems to be one of your functions also, is being a writer to explain these technologies.
Right, yes, and as I talked about, with the job that I have, what I like about it is there's so many different aspects. There's some coming up with new technologies, there's presenting at conferences, there's some sales aspect to working with customers to show them the benefits of our technologies. A lot of times we'll do a trial at a customer where we'll say, we'll set up some parameters, we'll bring our flow controls and our engineers in and basically run a trial for a 6-week period or a 2-month period.
Just to show them.
Demonstrate the benefits and say, okay, as we said, we've increased your production by 20% and we've done it this way or that way. So the job itself, I think, is very varied, and you and I had talked a little bit earlier about getting young people into the industry. These kind of jobs, I think, are very, very interesting because you see so many different operations, you meet so many different people, and as you know, no two operations are the same.
Yes.
You think you've seen everything, and then you go into another plant, and wow, that's a new way of doing it, a new furnace setup. So that you're always learning new things to do.
And do you see some new technologies on the horizon that Air Products may be already starting to work on, that may be coming to different installations?
Yes, there's some stuff that we unfortunately we can't talk about too much, but certainly we do a significant amount of research. The group that I have has about 5 or 6 engineers just working in the metals industry. There's a research group that has probably twice that number of PhDs and lab technicians. We have very significant combustion labs. So we're constantly developing new technologies and new, whether it's combustion, whether it's blanketing, whether it's work on degassing. We're always looking at ways to improve the operation of our customers.
Where are the labs?
The labs are in Allentown, Pennsylvania. That's Air Products headquarters. There's about 3,000 people in the Allentown. And worldwide, I think there's probably about 20,000 people at Air Products.
Okay, well, it's been very illuminating talking to you. I learned a little bit about Air. Thank you very much.
Well, thank you very much for the opportunity, Emery. Okay.